Alright, Electric Component Division, Service Department, Locomotive Service Manual, Part C, Section 6, SD45, Locomotive, Exciting System, Turbocharged Locomotives, Figure 6C1, Silicone Controller Rectifier, or SCR. Indicated in Figure 1 of the three phase alternating current with excitation AR10 traction alternator taken form of the D14 alternator. The D14 alternator is part of the AR10 assembly being mechanically coupled to electrically independent of the traction alternator. The D14 alternator output is fed within rectifier with the silicone controlled rectifier assembly. The silicone control rectifier in Figure 6.1 operation of silicone control rectifier is controlled by the trigger magnetic amplifier called a sensor. Figure 6.2, the rectified control current is fed with the AR10 traction alternator field windings. Figure 6.2 shows the sensor trigger magnetic amplifier. Figure 6.3 shows the result of the use of the rectifier with the D14 current with the AR10 field excitation without the benefit of the control device, as can be seen with the control over the AR10 excitation with control come from the engine speed with considered with the high level of excitation available through the D14 alternator. The engine would overload in all throttle positions. In Figure 6C4, the three diodes of the rectifier bridge have been replaced with the silicone-controlled rectifiers, or SCR. Since the silicone-controlled rectifiers will block the forward direction of the turn-on signal applied at the gate, no current passes through the bridge of the AR10 field. 6C3 with a D14 current used in excite the AR10 field without the control device. You have your D14 motor excitation or alternator. You have your alternator going through the ground field relay. Your rectifiers in three different lines from the alternator to the AR10 field traction alternator field windings. Figure C4 silicone controlled rectifier placed in the rectifier bridge. D14 alternator CAB are your lines. You have an anoid and a ground free relay cathode at the gate. CR silicone controlled rectifier parallel circuits 1, 2, and 3, and AC controlling fans 1, 2, and alternating current 1, 2, and 3. AR10 field windings. In Figure 6.5, the switching device has been added to connect all the signal with the proper value for the D14 alternator to the turn on the silicone controlled rectifier. If the response for the switching device is extremely rapid and sensitive touch for the switches can be closed at a proper instant, then immediately open and select the increments power available from the D14 alternator is identified with the wave through form can be sent for the AR10 field with the switch closed early with the cycle of the strong excitation signal is available. If the switch is closed late in the cycle, a small excitation system small excitation signal is given and the switch is closed with the midway in the cycle. The intermediate signal is pictured in Figure 6C5 is available. Now, note without the output of the silicone control rectifier bridge, intermittent current flow over the AR10 field maintains relatively stable at average level because of the freewheeling of the diode connected around the field's alloys. Current flow prevents immediate collapse of the magnetic flux around the alternator field. Alright, Figure 6.5 shows the switching device connected to the silicone rectifier gates. Also, you have shaded area indicates the output from the rectifier bridge, and C, A, and B from the cables from the three-phase windings from the alternator with a ground free load relay on AC1 and AC3. Also, cathode A, B, and C on silicone rectifiers 1, 2, and 3 circuit and parallels. And alternator field winding switching devices from the alternator to the rectifier, one side of the rectifier. Alright, this sensor, the obvious mechanical switching device, cannot respond rapidly and enough for the effective achieve of the portion of the AC cycle. The lower power trigger of the magnetic amplifier called the sensor is used sensor through the associated device called the bypass panel matched with the reference signal from the locomotive throttle load regulator with a feedback signal with a proportional with the AR10 output. When the reference signal is stronger than the feedback signal, the sensor puts out with the signal proper instance turn on the silicone controlled rectifier. Silicone controlled rectifier automatically turns off the moment of the AC cycle when its cathode becomes more positive than its anode. Stronger than the reference signal with the relation with the feedback signal with the sooner with the AC cycle with the sensor will trigger with the silicone rectifier with the greater the amount of the traction alternator installation. General discussion of magnetic amplifier operation was given in Part A of this section. The following more specific discussion of the trigger magnetic amplifier sensor figure 6C 6 is generalized schematic diagram of the sensor. Figure 6C shows the sensor silicone rectifier, control rectifier. Once again, you have your D14 alternator A and B and C windings going to alternating current parallel circuits 1, 2, and 3, and the ground relays 1, 2, and 3. Silicone rectifier 1, 2, and 3 on the alternator field rectifier in between. Closed. One set silicone rectifier is the other side. Pot heads. You have your transformer in between the D14 alternator field windings and the bias adjusting rheostats, choke coil, 72 volt DC. You have your transformers 1, 2, and 3, current volt feedback, reference signal, load regulator, signal bypass transistor. Alright, note that it consists of the 3 separate triggers with the magnetic amplifiers, each related to the particular silicone control rectifier. With the trigger of the silicone rectifier is turned related to the same phase from the D14 alternating phase relationships well within the proper sequence must be maintained. However, the following discussion with the sensors, only the trigger of the signal of the figures will be covered. The moment the depiction of the figure 6C7 occurs during the period of the phase wave. On the illustration shaded there with the primary terminal number 4, the sensor transformer is positive primary terminal number 12, negative the transformer is wanted. Secondary terminals A and C with all positive since the rheostat 16 RH is turned to the minimum resistant position. The current flow with agreement with the forward direction of the diode of the FRE or rheostat magnet flux condition to develop, and the saturated core indicated with the symbol OA1B. Shown on the graph lower left hand corner of the illustration. Alright, this shows the basic flux setting of the saturated core. You have the time wave, your current, your saturation, flux and coil current, positive and negative, sim wave, D14 alternator, windings A, B, and C. Also on the outside of A and B goes to the transformer. Clockwise rheostats on the left side, and then the relay from the transferring saturatable core choke. Then back over the RAT alternator field winding core, you have your A, B, and C winding with silicone rectifiers and gates at G and G3 and there's only a negligible leak current flowing through the 6RE, assuming the no current CD and winding from the moment of the, you assume the no current with the 1920 windings. In figure 6.3C8, the polarity of the transformer primary has been reversed. Primary terminal with the number 12 positive, terminal number 4 negative, with the secondary terminals B and D are now positive. Negligible leak current flow through the 5R rheostat relay. Current flow 1 and 6 rheostat working opposition flux developed during the previous half cycle that derives saturation of 0 to 1 AB with the back with the 0 to 0 shown on the graph of the 6 figure 6C8. The specific note with the current with the 1 DC is working with a change with the saturation level of the core lower voltage drop across the core winding located with the 6E rheostat and 1 rheostat. Therefore, only the small potential for the sensor for the terminal number 14 silicone gate number 3 parallel circuit. This is not great enough to turn on the silicone rectifier 3 parallel circuit. Alright, I have overcome basic flags, saturated core, IDC, flux current, cool current, positive negative, DC14 alternator, past C and B going, C and A going through the transformer, A and B and C and D terminals, the rheostats and rheostat rectifier, clockwise rheostat, resistors, 4R and 1R, 6R pot-headed reactor, saturatable core, large voltage drop, and silicone rectifier gates number 3, and on the C line, C and B line, alternator field winding. In figure 6C9, rheostat 1 16RH is returned with the counterclockwise, increase the resistance, reduce coil with the current lab through the flux intensity of the 01 AB is less than previously. However, the coil 1D IEC has now been reduced to flux intensity indicated with the graph carried up past 0 of the 01 DC. Once again, you have the base bias towards the saturation level, the coil current IAB to the IADC from the flux current intensity less coil current flux shift the IAB on the downside of the negative cycle and IDC on the positive cycle. You have the D14 alternator 3 windings, B, C, and A. C and A are running to the transformer, and then they have a resistors 4, 1, and 4 and 1, reactors 6 and 5 and 6, rheostat 16H, saturatable core, and 19 and 20 terminals. You have your silicone rectifier 3, gate 3, and then alternator field winding. Alright, in figure 610 with the 16H rheostator has been further increased with the coil current lab, further reduced to A again with the coil current 1 DC remains same level. The flux core is driven at the point of the saturation flux line spill out of the coil with the voltage drop shown in figure 68 is no longer the curve across the coil. The drop is seen with across one resistor, number 1 resistor, resulting in single with the gate with a silicone rectifier 3. Turning on the control rectifier. Note that the portion of the half cycle is necessary for the saturate current determines if the portion of half cycle of the silicone rectifier 3 will turn on. It will flow for the amount of the current developed. The AR10 field alternator field widening related to the time and the period of the silicone rectifier is turned on. The purpose of the choke of this circuit with the carrying on the signal of the silicone rectifier to improve the duration of the turn-on signal, ensuring that the signal is present in the time period required for turning on the inherent characteristic silicone controlled rectifier. Alright, this shows your coil current A and B saturated to core time, which means the from the transformer, which would be, and also what they want to see is the alternator running from the C winding, A winding, through silicone rectifier on the turn-on signals, back through silicone rectifier 3 through the alternator field, and then on back through the A wind, and like on silicone rectifier 3. In figure 6C11, the 16 rheostat of the resistance comparable to indicate with the 6C9 with the setting of the negative magnaflex normally obtained during the first half cycle of the U with the indicator of the graph of the figure 6C9. However, the current is applied 1C is applied through the 19 and 20 coil negative of the flux condition, reducing approximately the point shown in figure 6C10. Know that during the second half cycle the core is deriving saturation. Silicone rectifier is turned on. It can be based on the stronger current through the 19 and 20 coil, though longer period of the turn on the SCR rectifier, the greater the amount of the excitation current of the AR10 field also flows for the current flow reverse coil as the flow of the 20 to 19. The degree of the negative saturation increased with the silicone rectifier parallel circuit 3 on the alternator field winding, and the 16H rheostat will be the minimum of the current of the 1920 coil, resulting in the silicone rectifier minimum turn-on time comparable to rheostat. Adjacent trigger magnetic amplifier set with a like fashion base balance output obtained each leg of the silicone rectifier bridge. Alright, so C and A make the silicone rectifier from the alternator to the alternator field winding, but at the same time you have Your B current, your silicone rectifier, then gate 3 is running back to the in between the transformer rheostat number 1 and on transformers 19 and 20 coil the saturated coil back to choke, and then do the gate and the silicone rectifier circuit. Alright, controlling the signal of the sensor. The sensor in conjunction with the sensor for the bypass panel with the silicone rectifier bridge with a rate with the control of the RCP with the perform the function of the early module locomotive using the D14 alternator power to generate the excitation performed with the polarized relay or PLR polarized relay transformer transistorized device with the PLS which is PLS heavy-duty magnetic amplifier sensor for the manner similar to device to used in the earlier system responding to the following. At locomotive standstill during the starting of the central response, the signal of the throttle response panel with match begins for the current voltage feedback signal with the traction alternator load regulator is in a maximum field position. During the general operation, the sensor responds with the signal of the load regulator match with again so the current and the voltage feedback for the traction alternator. At locomotive speed with the calibration device provided with the feedback signal of the system notified the load of the regulator control signal with the optimum power available to continue to extend with low speed heavy drag operation. Having seen the strong signal through the 19 and 20 coil, the sensor will bring the early turnout. The silicone rectifier result with a strong excitation of the alternator field winding AR10 with a high power output with a weaker signal through the coil, bringing out the later turn on the silicone rectifier lower than power output. Basically, the strength of the signal of the sensor is controlled by the load regulator, which is determined by the control of the engine governor of the other devices, namely throttle response panel with the rate, the control panel effect with the strong strength of the load regulator signal put on the load regulator with the primary engine output with the controlling device load regulator 1500 ohms taped with the plate with the type of the rheostat. This device is hydraulically operated vane motor with the pilot valve to the engine governor control with the flow of the engine under the pressure device vane motor clockwise or counterclockwise through the maximum arc of about 300 degrees, thereby positioning the rheostat brush arm regulating the output of the traction alternator by varying its excitation in the field. The load regulator pilot valve of the engine governor moves up and down one port and down one port and down to the open to the another port, directs the flow of oil to the proper side of the vane motor when the load of the engine demands more or less fuel for the engine set adjustment of the governor to receive the given throttle position. For example, the increased load would cover the momentary slowdown with the engine rotating speed immediately with the governor will react to increase the injection fuel to maintain the specific engine speed called the given throttle position. The governor mechanism for the move of the provided more fuel is also open. Load regulator pilot valve directing flow of the oil to drive the load regulator direction of the curve of the reducing generator output, reducing engine load. The combination increased the over the reduce the generator output curve of the engine speed to increase as the speed return to this curve the throttle setting the governor mechanism will assume the normal fuel position. For the throttle setting, thereby closing the pilot valve, stopping the load regulator stable position, and in this manner with the load regulator allow for the engine to maintain a constant rotating speed power output to each for the throttle setting. The cartridge for the control system that allows it to override the load regulator provided with the optimum power to maintain with the combination alternator potential of the GPT alternator current transportation with the provided with the feedback of the signal with the sensor bypass panel with the number 20 terminal of the sensor. Feedback signal will match against the signal with the load of the regulator throttle response panel controls traction alternator excitation. Note that the sensor itself is entirely capable of matching with the generating feedback signal with the load regulator throttle response signal. However, it is ensured that the turn on, turn off and all levels of excitation transistor U with the effect increase the sensitivity of the sensor, bringing about with a precise response with the feedback signal with the transistor located on the call with the sensor bypass panel. Ensure that the sharp turn on, turn off going through the sensor 1920 windings and it does not amplify the signal through the sensor. The feedback system. In Figure 6C12, the show of the high current transformer are used to be in signal supply a signal with the proportion of the traction alternator DC output current. Total AC current does not pass through the transformer, but rather than the AC from the one of the 10 legs in each phase. In fact, with the current transformer sends approximately 1/10 of the total generated current output of the transformer, with the loading resistor R3 called to provide the voltage signal in proportion to generated DC current. Figure 612, the general application for the current transformer to current feedback operation. You have your excitation field windings down here, C, B, and A, north, south, and poles, 1, 2, 10. The 500 D5 current transformer, well, actually, let's just start. Let's say that it comes from the A, B, and C terminals and the loading resistor with rectifier, the sensor of the transformer, are running on 3 different parallel circuits through the bus load and bus bar, and in the circuit, there's a feedback signal. Alright, figure 613 show with the graph relating with the current feedback signal of the main generator amp the DC with the slope of the line with the graph can be changed by changing the valve of the resistor 3. Resistor 3. Causing extremely high damage of voltage will appear when the secondary current transformer. The circuit is open with the current of the path with the primary. Capable of the proper resistance value with the shown with the resistor 3 with a 50 volt DC can be obtained with the 3900 amp as the main generator. It may be noted here that the voltage drop across the load regulator is also 50 volts with feedback signal with the verified amounting of 400,000 amp the shunt and a bracket provided with the locomotive. The shunt will short the circuit with the main generator. In figure 614, the means that has been added to give the DC voltage signal proportion of the DC voltage from the traction alternator. The AC voltage developed in the AR10 alternator field windings is directly proportional to the DC voltage of the AR10 field power rectifier assembly. It is only necessary to transform the AC voltage to usable value, rectifying the current path through the current through the proper value resistance R1 and resistor R1 and R2 current, parallels or current series to obtain the DC signal proportion of the traction alternator DC voltage. In addition, with a high voltage 3-phase AC source, we were available to apply with the primary potential transformer. Our figure 613 shows the current feedback system. The main generator amperes 0 to 3900, running at a slope of making the equation x y equals mx or 39 over the 50 volts over the slope of the line makes let's say 1 in 50. So your YMXB would be between 50 volt rectifier signal and current transformer. The main generator amp to DC. 3900 and voltage show the short circuiting metering shunt of the 1, 2, 3, 4, 5, and 6. The alternator field windings going 1 and 4, 2, 3, and 2, 5, and 2, 6. Current feedback. Resistor 3, silicone rectifiers or pot heads by the triangle of the slash. Alternator field winding 10, A, B, and C going to general potential transformers. Resistor 1 and 2, while the shunting circuit meter in 1, 2, 3, and 5, and 6, and current feedback signal voltage for resistor 3. 6 feet current and voltage feedback signal connecting to added. You have the main generator field volts DC between 1100 voltage, 1200 voltage. DC shown 36 horsepower and main generator ampere DC, creating a line with the sum of the voltage drop of the resistor 2 and 3 equal to 50 volts at any point with the power of the center of the line. 3600 horsepower curved differential engine governor control load regulator. Once again, you have your alternator field winding going through transformers and then rectifiers. Three windings for resistor 1 and resistor 2 on the same circuit. Sensor terminal number 20 with the transistor. Three of the windings going to the rectifiers, shunting meter system 1, 2, and 3, and 4, 5, and 6. Also rectifiers, resistor 3 bridge, silicone rectifiers. Alright, the GPT loading resistor R1 and R2 would be bringing the feedback with the voltage signal that indicated with the graph that's figure 614. The full 50 volt feedback signal would receive with the 0 amperes out of the main generator. In figure 6C15, a tap has been connected between the resistor 1 and resistor 2. The produced voltage divided with the feedback signal with the resistor 2 and resistor 3 connected in series with the voltage added with the effect of the increase of voltage similar with the obtained connecting two batteries in the series. And if a straight line is drawn between the voltage point with the voltage feedback signal is equal to 50 volts at 0 amperes with the main generator to the amp of the point at the current with the feedback signal is equal to 50 volts at 0 volts of the main generator, it is found that some of the two feedback signals will be equal to 50 volts at the point of the line, straight line closely parallel to the position of 36 horsepower curve. The U of the locomotive is traveling at 17 miles per hour faster. Assuming the two feedback signals is compared to the voltage from the lead regulator arm. This is done by connecting two negative together, then tying to the positive side of the feedback signal of the load regulator through the sensor bypass transistor. Figure 6C16 will controls the current in the 1920 coil of the trigger magnetic amplified sensor. Refer to the pack to figure 6C6 through 6C11 related. Our 6C16 shows the application of the sensor bypass transistor field coils 19 and 20 saturation from the transformer, from the sensor bypass transistor load regulator, and feedback signal from the main generator. So there's your sensor, okay? Thus, there's any imbalance of the voltage between the load regulator arm and the feedback signal will result in the current flow with the sensor bypass transistor. And the sensor 1920 coil with the current flow through the 1920 assists the saturation sensor core. The value of the current of the flow to determine the turn-on time silicone controlled rectifiers, thereby controlling the traction, alternator field excitation, and locomotive power. Alright, the power control system, figure 6C17, shows the feedback signal connected through one of the three triggers of the sensor of the load regulator tab. The sensor is connected with the silicone control of the rectifier assembly silicone rectifier. Blocks diagram indicated the 72 volt DC control current was applied with the throttle switch with the throttle response for the TRP panel. Then the rated control panel, RCP. Then the load regulator drops approximately 25 volts to curb the device and full throttle with the load regulator maximum field position potential of the load regulator taps about 50 volts. With the potential across the sensor bypass transistor, no current flow with the 1920 coil with the silicone control rectifier does not turn on the AR10 or alternator field widening excitation leading decline of the resultant over the drop of the feedback voltage. Drop feedback voltage between about the current 50 coil, the 1920 coil, the silicone rectifier, turn on bridge, bringing the voltage across the transistor again to the balance point. During the operation, the throttle 8 speed over the 17 mph engine governor load regulator will normally act as the locomotive power resistor control device. The power point determined with the traction alternator amplitude voltage and falls somewhere in the dark portion of a 3600 horsepower control shown. Alright, you have a G14 alternator going through silicone rectifiers 1, 2, 3, A, B, and C. A and B, is B or C, run through the saturated, the transformer, the resistor 1, resistor 2, rectifier, resistor, saturated coil number 9 and 1, a resistor rheostat, 16H, sensor in between the, current control device, throttle switches, throttle response panel, rated control panel, resistor, left, right, sensor bypass panel, show the, which from coil 19 to coil 20 and 19, show the, what was I getting, like, saturated sensor transistor load regulator, feedback signal main generator, 2, resistor 1, 2, and 3, the current transformers, rectifiers, in between, parallel lines 1, 2, and 3. The 3 windings from resistor 1 and resistor 2 and resistor 3, and you have a GPT, another saturated transformer, negative running from the to resistor 3 and on the line of resistor 1 and 2 and 3. Alright, in figure 6C18, however, the consideration variable quantity with the condition fuel aim and temperature air pressure for the fuel meeting with the engine injected with the horsepower curve that may be shifted with the right indicator as the right indicated with the upper dot curve. When the wheel slip action, the curve of the power curve is shifted with the left is indicated by the lower dotted curve of the load regulator. Insert electrical resistor and feedback sensor bypass transistor sensor responded to produce the power level the call by the change load regulator position. Text related to the figure C18 indicates how the control system compensates for the variable as not controlled by the load regulator. 6C19 show how the power control system regulates provide with the optimum power train speed between 11 and 17 miles an hour. Our 6A18 show the load regulator control locomotive power, the traction motor alternator volts in DC 1200, 100 to 100 traction DC, traction alternator DC to 4000 on the X-axis, Y-axis traction alternator voltage DC 0 to 1200, power reducing wheel slip, the horsepower fluctuation due to the quality condition of the fuel, ambient temperature, air pressure metering. A line is drawn between the power control limited is determined by the balance of the 50 volt DC across the bypass panel, and there has a 3600 horsepower curve. Alright, from the rated with the control panel with the 50 volt DC, going through the load regulator rheostat to around the corners, where the performance control panel, which runs into rectifiers, the current transformers, 3 parallels, and holes in between a resistor, and then in between them, from that, after the resistor, you have the top 72 volt sensor coil, 19 and 20 sensor bypass, from running from rheostat 2 and 1 on the GPT transformer, or should be the main generator. Alright, observe that there is a single power with the control line, no change with the slope, with the same power with the control characters, you with the compensate with the variables with the maintain power with an optimum level of 50 volts available. The load regulators match across with the sensor bypass transit for the 50 feedback volts. The slope of the line provides optimum power with the overbinding with the traction motor. The train speed of 12 miles an hour with the traction alternator amp to DC at approximately 30,000 volts. The traction motor are connected with the series parallel to the traction alternator. Each motor will carry about 1,000 amp as they approach with the continuous rating of the train operating at a slower speed. High amperage within there is restricted. The power control system by the third function of the regulating power of the traction alternator, nominally 3,000 horsepower with locomotive speed below 111 miles an hour. The locomotive will work at optimum speed power with adhesion consideration consistent with the power for the locomotive. The third function is accomplished by again changing the slope of the power control line. The change is called the performance control. Alright, let's go over the 619 power control, 11 to 17 miles an hour, 16 to 15, 60 to 15 gear ratio. Alright, we're talking about your traction alternator voltage DC 0 to 12 on the Y line, traction alternator amp DC on your X line. Train speed nominal at 11 miles an hour, train speed nominal at 17 miles an hour. Making a power control line moves with each of the changing of the throttle positions, 306 horsepower bypassing sensor somewhere on the right side of the train speed, 111 miles an hour at 50 volts DC. Once again, you have a 50 volt DC from the rate control panel load regulator going around to the resistor 3 and on the 3 parallel sides of the current transformer coils, current transformer rectifier, and then meeting 72 volts and 19 and 20 coil, the sensor bypass 50 volts DC is going to rheostat resistor 1 and 2 on the main generator, or GPT. I believe that is the main generator transformer current. Our performance and control. In Figure 620, with the circular blending of the power of the control line have been added with the shown Figure 619, a more complex pictorial diagram providing the 6C21. Remove the flyer on the rheostat 7 forms the regulator voltage. Resistor 7 forms the voltage reference with the feedback with the voltage point with the A with the Figure 6C20 less than potential established. Figure 620, so for the performance control, the traction alternator voltage DC at y-axis 1100, 1000, 1200, 1000 to 4000, and alternator amps DC 0 to 1400, but past it is point C. We're looking between the points B and C. Train speed nominally 11 miles an hour, 3000 horsepower, 36,000 horsepower, and we got to go over the diagram. Alright, stable 74 volt DC, riding around on the rheostat 5, 6, and 7. On the positive control system, positive control panel, 50 volt DC load regulator going from the sensor bypass, which went through the sensors coils 19 and 20, which also runs on the outside of the resistor 3, which will meet up after it meets point A on the current on lines of current transformer. Resistor 3 will meet up after A to resistor 2 and 1 on the solenoid rectifier 3-phase transformer in the power control panel. Slide resistor 7 and block rectifier with a circuit to prevent the current flow for the 72 volt DC. So for that rheostat 3, however, when the feedback voltage point A is greater than the reference voltage of the listed electrical resistor, is parallel to the resistor 3 loading the current transformer increase the takes for the greater current with the transformer primary down with the reference voltage feedback voltage. The adding loading current transformer move the amperage anchor with the point with the control line right with the step of the farther right with the decrease of each of the generator field maximum point with the power being determined the resistance value with the performance control bleed circle with this extent, which is power control. Line fans and over the right determine the value of the resistor 4 and resistor 5. The resistor 7 is a significant instance of the because it is relatively small value. It follows follow with the generated current with the increase of the point of the feedback voltage slider a tab of the rheostat 7, resistor 7, and everything high enough for the current, cover the current flow with the performance control circuit with the added loading of the current transformer. The power control line will move to the right with the greater volt value with the main generator current with the further the power control move with the locomotive power instead of being limited along the line anchored at approximately 3,900 amperes with it now limited along the new line and slope of the which for the determine the value of the resistor 4 and resistor 6. Valve figure 6C 21 performance control pictorial diagram basic set SD45 system with a motor cutout circuit. Show the alternator field winding 3 phases going for the current transformers. Alternator currents 1, 2, and 3 are fans, which was in a different section. Alternator currents A's 1, 2, 3. Alternator field windings, current transformers, 2 alternator rectifiers at the main generator. You have the dots 16, 18, 10. They're scattered around here. That I don't know what they mean. But moving from the so let's start with the performance control panel. You have resistors. You have 2 different sets of ACs and ACs from the main generator. Also from performance control, you have rheostat 8 and rheo 3 and 8, and the silicon 3 rectifiers, 3 parallel circuits until it meets 3, 16, 8, and 10. 3 rectifiers. I believe these are it's called 16, 8, and 10 rectifiers, and then continuous COR. Push buttons, rheostat, a load regulator, your rate control panel, negative throttle position panel, sensor coil, sensor bypass panel. Alright, for resistor 4 and resistor 5 were offered an infinite resistance slope, but the performance control line would be such for the extent of the point B with figure 620. With the resistor 4 and resistor 6 lesser resistant main generator amplifiers could theoretically increase the point C with the performance control line with the slope of the terminal point to the infinite the number of the power control lines, ending with the line instruction intersect the amplifier exit axis for the point B. And the resistor 4 and 6 with the yet lower resistance amount of the using the SD45 locomotive with the main generator amplifier could theoretically increase the point farther than the right of the graph. Slope of the performance control line would then be indicated with a heavy line closely parallel to the 3,000 horsepower curve. In function of the performance of the control circuit would allow the locomotive to operate in the manner consistent with less powerful locomotives at a heavy drag lower speed. The higher locomotive with the speed with the traction and curve with the condition with the performance control would unnecessarily restrict the locomotive power. Theoretically auxiliary interact with the relays but related to the transition U with the connection performance control panel with the resistor 1111. Figure 620 was one of the parallel rate control panel resistor located with the feedback of the rate of the control transistor. Change of the voltage dropped across the load regulator 50 to 56 volts and the move of the amperage anchor point with the power control line with the right. And since the performance control need is effectively evaluated figure 622 with the point beyond 3,600 hours power load regulator curve. Figure 622, 6C22 with the performance control power and power control lines reposition basic system under control traction alternator voltage DC on the y-axis traction alternator amperage DC basic control pickup of the auxiliary shunting relay brings the power control performance control lines position above the load of the regulator control. Special performance control condition shown figure 623 and the resistor 11. Maybe the connect with the parallel resistor 3, additional resistor 11 and 12, the connect with the series with the resistor 1 and 2, with the chain with the voltage current anchored points of the power control line, slope of the line chain with the bring above the effective load. Transaction alternator voltage DC, y-axis traction, and alternator voltage amperage DC. Show the speed control system pickup of the auxiliary shunt relay brings the power control with the performance control of the center line with the position above the regulator control. Figure 623 show the performance control and the power control lines reposition special system. Regulator control with the first step of the motor field shunt when it has occurred. The throttle response panel, or TRP. Your excitation system is described at the point with the assume with the fixed voltage with the input with the load regulator, the traction alternator, excitation with the verified with the chain with the position load regulator with the rheostat brush arm. In order to change with the potential with the feedback signal must match the current with the sensor bypass transistor. This valve, the load regulator is held with a given point. Traction alternator excitation can be verified with the input of the sum of the device and chain potential input with the load regulator. Figure 624 illustrates the throttle response of the throttle response panel that is employed with the throttle position number 3 part of the throttle response resistor shorted out with the throttle response relays number 3 and the number 8 position and the entire resistor shorted out and throttle number 1 position the entire resistance in the circuit. This makes the starting effort locomotive directly related to the throttle position. Observe that when the throttle is in idle position, interlock with the ground field relay, prevents the overlighting of the solenoid or over ORS being energized. Consequently, the load regulator maximum position during the locomotive starting effort is controlled by the throttle position through the throttle response panel. Deficiency increment power is available to each of the throttle position. Power is available almost immediately. The power, however, is at lower. Figure 6C24 show the throttle position of the panel diagram. Show the throttle switches closed with the throttle position. These are push paths from 3 through 8, 2, 4, 6, 8, 5 through 8, and 5, ST stop in 5 and 6. You have a negative A, B, and C, D line terminals. A ground feed relay on the EW wire meeting the throttle response resistors, double gated rheostat from switches, relays running from the resistor rheostat on the EW wire. From also making contact with the circuits from the throttle switches closed in the makes relays to the array with the control panel, load regulator negative. Also, there is a sensor bypass transistor generator feedback sensor coil 1914 and rheostat resistor at 72.4 volt DC. Transpeat throttle position off and less value would be attained by the load regulator action alone. The effect should be evident with the power control curve shown in Figure 6C19 shifted and corresponding with the horsepower available successful low throttle position. Alright, your rate control panel, RCP, the response with the traction alternator excitation system with extremely fast with the consequently change with the throttle position with load regulator maximum field with the result with a sudden increase of the power that makes it necessary to control the rate of the train within the traction alternator excitation during the throttle change in order to preclude suddenly acceleration of the train overloading diesel engine. On the late model GP35 and the SD45, the locomotive is equipped with the throttle response panels rate the train with the control of the shorting magnetic amplifier rewinding with utilizing the delay inherent with the response with a heavy-duty magnetic amplifier. However, no such delay inherent response with a sensor silicone controlled rectifier assembly supplemental device must be used to provide the delay. Same supplemental device also used to enable the smooth application regulation dynamic brake control device and rate control panel. The rate control panel schematically illustrated in Figure 625. Essential components to be used in the non-negative, positive, negative of the type of the transistor, resistor capacity, type circuit changing with the throttle position, dynamic brake rheostat position, result of the change of potential impressed upon the base for the transistor potential base control with potentially the emitter with consequently the signal to the sensor with the bypass by change of the potential control throttle brake brake handle to the abrupt rate. Abrupt and rapid the rate of the change control with placing the capacitor between the transistor base and the negative and insert the specific resistant value feed with the transistor base. The rate of the change is harder with the capacitor through the resistor of then control of the rate of the change of potential of the base of the transistor with the result of the change potential of the transistor meteor that. Alright, you have your negative of 50 watt resistor BWR push button relay a 100 UF capacitor. These are capacitors running the 100 UF capacitor, negative 5 and 6, meeting place, DBR switch in your regular control panel. They had positive, negative transistor. Your silicone rectifier at a veneer, 24 volts, another rheostat, load regulator, negative bypass transistor going in the transistor. And then from the rate of the control panel, you have the BR switch. You have your ground fed relay, a dynamic brake and rheostat. Your resistors, and these rheostats actually turn the throttle positions on the throttle response panel. Alright, rate of change during power operation. The upper portion of the figure 6 drawing C with the throttle is in position the number 1 voltage obtained with the cross throttle response resistor of the result of the potential form of the form 11 to 16.5 volts set by the throttle response panel, the rheostat, the number 2 terminal, the rate of the control panel, the current flow through the fixed 1.5K resistor panel with 1.5K resistor. The purpose of the rheostat rate of control panel, rheostat is precisely for the rate of control panel. The rheostat is precisely control the maximum output of the load of the regulator sensor bypass transistor. The current has also flowed through the rectifier through the 3K resistor through the 20K resistor. Negative voltage drop result of the small potential base of the transistor. Same with the transistor will turn on potential with the small emitter will exceed the potential with the base. The potential emitter is maintained with the base for the potential. The throttle position chain will indicate the low portion of the figure 626. 6C26 for the voltage drop, the curve of the throttle response resistor chain with the potential of the rate of the control panel, terminal number 2 and 28.8 volts. However, the moment of the chain with the potential of the base emitter with the transistor remains the value obtained with the previous throttle position. If the increase of the control of the rate of the control panel terminal number 2, the resistor increases on the current through the 3K with the resistor, the sense of the potential of the capacitor still was what with the previous throttle position must increase with the current flow directed with the chain with the capacitor. Some of the immediate increase with the current flow indirected with the capacitor with the little immediate increase with the current flow for the 20K resistor. Therefore, the large voltage drop that's seen across the 3K resistor is the potential base of the transistor is not suddenly increase with the capacitor charge with the greater portion of the voltage drop that across the seam of the 20K resistor. The time of the change of the capacity determined the side of the capacitor rate of the current flow through the 3K resistor permits. It flows the same rate with an increase will take of the latest sensor bypass panel with the sensor terminal number 819 with the consequently gradual with the traction alternator field excitation traction alternator output. The rate control panel has been calibrated to sudden chain with 0 to 72 volts. Terminal number 2, the rate of control panel will result with a chain with 0 to 50 volts at the emanator transistor at a time of the 22nd. Small potential changes will then play for the comparable rate. Alright, the 626 C26 is show the rate of the control panel function simplified schematic. Negative, running the load regulator sensor bypasses the transistor. Also, the negative going through capacitors, terminal 5-6, 20K resistor, 4, moving from 6 to 4. Actually, let's go from the 74 volt ground from GFR, which reads that holds the idle spot. So position 1 through 8, the resistor voltage drop goes to terminal 2, 28-volt DC. Also moving to the rectifier through number 1 through the 3K resistor number 4 back to number 6. Then the capacitor number 5 and 20K volt. The transistor current air change of the air transistor change the air base in between 2 and 8 with the rheostat 1.5 K resistor rheostat 1.5 resistor 8 through 3. Load regulator rheostat negative bypass sense bypass negative. Alright, the top, you also have your 70 ground free relay, which is the throttle position at 1 through 8, 72 volt voltage DC, the droppage go through the voltage terminal number 2, then 2, where the negative reaches a 4.5K resistor through a rectifier, and 1 and 4 with the terminals on the rate of control panel, 3K resistor in between 1 and 4, moving from 4 to 6, with a small potential going to a 20K volt negative, also meeting at the transistor point B, and then 6 to 5 with the capacitor with a negative, running back to the line from the resistor of the 72 volt DC for the resistor and throttle position. You have the terminal number 211.16.5 voltage DC meeting the 1.5 rheostat, 1.5 resistor, and terminal 8, and then to the transistor where you met the terminal 6 and 8 and 3 meted the transistor control of the flow through the load regulator, and then the load regulator maximum to the base of the sensor transistor negative line. Rate of change during dynamic braking operation. The same device with the control of the rate of the power chain with the control of the rates of the dynamic braking after the same minor chain with the U with the device the curve of the dynamic braking. The 24 volt linear diode becomes effective the contact dynamic brake relay after the 700 amp motor armature current. In figure 60C27, note that the brake control handle throttle level is in an off and idle position. The brake warranty of the brake warning relay WBWR. That's what that means. Dropped out ground relay rate of the control capacity. Consequently, very small voltage voltage will be present with the base with the transistor fail-safe arrangement brake and application of the generating isolation brake warning circuit, and not warning the properly brake warning relay must be picked up with a normal locomotive operation. Alright, once again, you have your 72 volt resistor, positive and negative resistors through the 14th step of the resistance on your throttle position. A TWH brake of the 24, I can't remember. This looks like a push button on the brake, which we're looking at the dynamic brake. So the THS brake, you have your brake relay, or BR, which is brake warning circuit, brake warning relay button, amp 24 amp 24A, meeting at terminal 1, 3 volt, meeting on a 3K voltage. The 74 volt DC large voltage drop 4K resistor goes to the 4, and then it meets into a DBR dynamic brake relay is 8 and 6 two terminals. Meeting place 4 and 6 going from the 8 terminals when really 50 watt resistor brake warning relay negative and negative capacitor on the 50 watt other line. 50 the capacitor going to a 50 from terminal 5, 20K resistor silicone rectifier 5.6 on the line of terminal 1 after it had met the silicone rectifier resistor at 1.5K and the resistor before it meets the rheostat in between the dynamic braking Xeneer transistor E, B, and C terminals. Load regulator 1.57 negative 4.5 kilowatts between the resistor and the transistor and the terminal 1 rectifier. Also 15 rectifier terminal 1. Alright, figure 628, the brake warning relay is shown picked up with the normal operation code condition over the brake control handle of the advance through the clove of the brake lever of the operation switch. This switch THS not far enough to apply with a potential 24 wire low resistance both the negative remove voltage drop and cost 140K resistor, reduce potential across the base of the transistor for reason for the application of the potential. You can see in the chart low right with the portion figure 6C28 without intentional potential then press for the application 74 volt DC the 40K resistor initial mode of the brake control handle would bring about no increase of the braking effort through the initial follow through the operator switch contact clove the initial flash drop of the brake ring response. Alright, you have 72 volt positive negative on your 14 step resistance between the brake control rheostat, your throttle, your operator switch hooked to the throttle position, your brake control relay, throttle control, operator switch, 24 line T and A brake relay button on terminal 1, 40K relay voltage drop 74 volt positive, running into terminal the dynamic braking resistor, which is basically a gate between 6 and 2 terminals through 6 and 4 going to resistors, rheostat or 6 of the transistor relay, small potential, brown brake warning relay on the other side of the 8 between the capacitor and 9. Alright, what we didn't see was the auxiliary generator rheostat on the next parallel circuit of 1.5 rheostat, 1.5K rheostat, the sensor, the bypass reference, and the motor field current amplifier, 24T wire, flat spiral response supply, application 74 volts at 40K resistor. In figure 629, the throttle has been advanced to apply the potential brake control resistor of the rear voltage drop of the current of the 3K resistor chain with the chain of the taking place for the rate of the which the current will flow through the 3K resistor chart with the rate of the control capacitor of the voltage drop of the capacity of the base of the transistor chain with the sensor for the bypass panel. Sensor flow with the same rate with the chain braking after it is increased accordingly. Observe it at all times the potential of the terminal number 1 with the rate of control panel less than 25 volts. Control of the transistor collector must be first bypassed through the 1.5K resistor, through the transistor, finally through the 1K5 with the rheostat with the negative. It is seen with the lower portion figure 628 with the 2 resistor, the voltage divider as the voltage T24T wire is increased with the 0 to 450 volts in the sensor terminal number 19 and increased with the 0 to 25 volts. Figure 629 brake control handle. Show the brake control rheostat with 74 volt resistance. Um, your 72 volt positive negative rheostat resistors for the brake control rheostat. Throttle handle 24 wire guiding on the operator switch to the brake control relay, brake relay, meeting at terminal number 1 to the 3K resistor, and then on a 4K resistor before it meets terminal 2 on the same line, 3K and 40K to 74 volt DC power low. Or you can take the 24A wire to terminal 1 to a rectifier. Which before or real dynamic braking is an Hero 1.5K, which has a resistor on its circuit and a silicone rectifier pothead on a negative 4 point. Also, the rheostat is connected to 24A, awesome from terminal 1 is a 4.5K after the rectifier and the rheostat. Then from the 3K, terminal 1 from the in between the 3K resistor and the 4K resistor, you meet meeting points number 4, dynamic braking terminals 6, 6, and 2, on operating switch and dynamic braking relay to your wheel brake warning relay, 50 watted resistors, negative capacitors to both the capacitors are going from the terminal number 8 to the capacitor number 5 of the 20K resistor. Terminal 6 also meeting 20K resistor, so there's a circuit between terminal 5 and 6 on 20K resistor, but the 6 goes into the transistor dynamic braking Zeniro, while 5 continues on the 20K resistor to the rectifier and then to the load regulator of the base over the bi-center load regulator negative 1.5 kilowatts. At a point to be understood here that the Zunier action independent with the transistor effective only when the chain of the potential is brought about with the brake rheostat position. In figure C6C30 with the brake rheostat has been advanced far enough to bring about more than 50 volts with the brake control rheostat at 50 volts with the brake control rheostat equal the voltage drop of 24 volts across the 1.5 resistor and the 1.5 rheostat load regulator with the zero connect for the 25 volts drop across the 1.5 resistor. Therefore, all the further increase the voltage drops appear across the 1.5K resistor, increase the drop of the equal to increase the apply with the voltage slow of the line changes shown in figure lower right portion of the figure 6C30. Or you have an accelerator generator at positive engine going through the rheostat and the negative terminal. Also on the second parallel circuit, you have the silicone rectifier meeting the second rheostat at 1.5 kilowatts and a bypass sensor 1.5 kilo resistors to the reference voltage. The voltage drops across the lower right resistor 25, the Zunier conducts 25. Once again, you have the rheostat breaker, the 14 step resistance 24T wire with the brake to the operation switch brake relay, traveling from the 3K resistor to the terminal 4 with the dynamic braking relay from the 4 to the, also meets up with on the second on the circuit with 5 and 6 with the 20K reverser, the dynamic resistor, one terminal. All right, we've seen this picture. All right, just listen to the writing to see actually where the path goes. Figure 6C31 illustrates when the brake control handle is removed, the potential of the brake control capacity greater than the potential for the 24T wire with the capacitor or 2-4 relay, probably with a 2 or 4 wheel tracks, I guess 2-4T wire with the capacitor discharge of the load of the brake control rheostat load regulator, same rate, increase take place with the potential of the base with the transistor file with the brake control capacitor discharge single with the senior base panel with the sensor decrease accordingly. Alright, brake regulating warning. The dynamic brake regulator DWR will operate with a contact for the move 8 and 6. Move 8 and 6. The dynamic braking strength exceeds 700 amperes if the observer with the figure 6C30 with the ray with the control capacitor no longer contact with the brake control rheostat. The capacitor will discharge through the 20K resistor instead of the 3K resistor shown in the previous illustration. Same stuff. High resistance brings show that we just look at the different paths it could take. High resistance brings about the slower the discharge 26 with the maximum with the 0 with the consequently the potential transistor base with the maintain with the value resulting in the new maximum of the dynamic braking strength without the regulation. However, the discharge rate is slow enough to require the slow operation of the dynamic braking relay with the They're greatly extending with the surface of the life of the relay with the contact of the type. The dynamic braking regulator DBR is set with the relay with the 700 amp through the dynamic braking resistor grid. The current with less than the 700 amp. The dynamic braking regulator contacts remain with the close to 8 and 2 shown with figure C30. It's figure C6C30 with the time speed weight with the brake handle position result with the brake of the current with the 700 amps and approximately 310 volts across the one half of the resistor grid. The Zeniro 1 constructed with the maintain with the 50 volt with the across the diode that will again do conduct the 50 volt apply with the will maintain a 50 volt drops regard left apply with the voltage. The reference of voltage appeared at number 4 terminal of the dynamic braking regulator is more than 310 volts across the dynamic braking regulator. Circular voltage of the center tap of the rheostat with 10 is greater than 50 volt for the current volts flow for the 4 and 5 of the dynamic braking regulator relay coil. The dynamic braking regulator contacts 8 and 2 with the open of the dynamic braking rheostat connection. Disconnect with the base of the array with the control transistor shown in figure C32 with the potential at the base of the array with the control capacitor decay the slope within the traction alternator field excitation brake current within the braking current drop of the 700 amp less than 50 volts appear. Center tap of the rheostat 10 with the dynamic braking regulator contacts 8 and 2 with no current flow through the dynamic braking contacts. Closing the contact with the brake control rheostat with the brake with the rheostat brake control transistor traction alternator field excitation increase with the rate of the control capacitor charge. The capacitor of the dynamic braking regulator circuit with the provided with the anticipation smooth without the voltage peak with the rate of the control capacitor slow with the rate respond for the system the result with the smoother operation regulator of the dynamic braking regulator function with the braking with the current normally will exceed 700 amps out with the braking warning with the circuit with the provide with the protection against the possible excess of the braking the current with the current sensing of the portion with the warning with the circuit that is similar with the regulating the circuit but set to operate with a higher current value with the brake warning with auxiliary relay. BWA breaks up with the braking current result with a 335 volts across the braking resistor grid with the brake warning auxiliary relay contacts operating with the circuit with the brake warning relay with an interrupt with the brake warning relay contacts operate with a turn on the brake warning light. Brake warning relay contact with the low resistance path with the rate of the control capacitor, negative with the potential of the base of the rate of the control transistor, quickly fall with the traction alternator field excitation, brake current, see figure 6C, 2033. Brake current falls with the brake warning relay with required to sharp with the rate of the control capacitor. Okay. Alright, no, the figure 6334 operating with the coil and the brake warning relay with the located with the chain with the dynamic braking attempt with the reverse lever with the improper position with the reverse pole layer of the brake warning relay pick up with the sensor capacitation circuit with the dynamic braking figure 635. The amount of the traction motor field current with the necessary during the braking during the braking is small with the considerable capacity of the AR10 alternator field winding generator consequently signal with the sensor to control the rectifier with the supply with the generator of the current excitation current must be closely connected to close with the control of the possibility of applying the motor with the field the current and feedback with the signal with the limiting of the resistance 2221 coil. This would be one pseudo-attributable with the sensor. Refer to figure 6C6 with a note with the 2221 opposition current 1920 sensor coil refer. Alright, figure 635 to the dynamic braking sensor coil with the terminal 21 and 22, push button 23, brake relay on the 4K after the 4K resistor, motor field windings, and the alternator field winding and positive and negative connections. The figure 611, the note with the magnetic flux grid with the current of 2221 coil with agreement, the negative flux 1 IAB with the opposition flux 1 CD with effectively reduce the saturation time, resulting shortening in the silicone control rectifier turn on time. The system reacts with the soft and the system responds from during the dynamic braking, increasing the generator excitation during the braking and seeing the decrease of the feedback signal while the result of the decreased case control rectifier turns on. 634 is the broken brake regulator and warning tracks lights. The dynamic braking relay with the terminal 2 and 6 with the turn on with the rated control panel resistor with the capacitor and then the capacitor with the resistor capacitor brake warning relay. Brake warning relay, brake warning and relay switch normally between the terminal 8 and 2 on the 13T wire, while the warning circuit is also connected to the show of the rectifier Zenir rectifier Z3 with a resistor on the 5 to 4 current of the rheostat 11 with the 2 resistors on the outside. Also on the split current with a capacitor going on the reverse dynamic braking coil, capacitor 21 Zenir rectifier. the near diode and resistor, the rheostat 10 resistor, rectifier, back in the diode, brake resistor capacitor circuit. Resistor 10 resistor with it, on the next resistor with a resistor, and then 4 resistors on the dynamic braking grid for the motor armature, positive and negative on the switch open relay. And that completes the locomotive service part 6 and 6, electric slicing system, turbocharged locomotives, electric motor division, SD45.